All right, guys, so I wanted to go through this question. This is one of the ones you did in your homework. I want to go through and talk about how you may have done it previously, but also show you a way that you can do it even quicker. And we'll talk about this a little bit more in class, but just to give you a little bit of a head start, heads up. All right, so we've got a fair coin being flipped 6 times. We want the probability of getting exactly 3 heads. All right, so we're going to need a tree diagram here. All right, so yes, I know, I'm sorry. That was cruel and unusual punishment. In the end, we end up having a total of 64 heads and tails there, right? And so there are 64 different outcomes that can happen, right? So what we need to do now is we're going to kind of go over to the side, and we're going to make our probability distribution table, which is, the question is, how many heads will I get? All right. So here's x, here's the probability that the number of heads is equal to x. Symbolism there is not too important, but we could get 0 heads, we could get 1, we could get 2, we could get 3, 4, 5, or 6. Now, you can go through and you can count those up, right? I know that there's only one way to get all heads, right? To get 6 heads. Similarly, there's only one way to get all tails. There's only one, right? To get no heads. Okay, how many ways are there to get 1 head? So there's 6 different ways. Okay, now if you'll remember our discussion from class, we know that if we flip a coin 6 times, what we're going to get here is the 6th row of Pascal's triangle. Okay, now that 6th row of Pascal's triangle is simply this: 1, 6. What would come next? So 15, 20, 15, right? You can count those up if you want, or you can just trust that the pattern that we found before is going to hold true. Now, we should be able to answer each of the questions at this point, right? We can say, what is the probability of obtaining exactly 3 heads? So that would be this one right here. So that would be 20 out of 64, right? So that's going to be this one, 20 out of 64. What's the probability of no more than 4? So that would be no more than 4. 5 and 6 would be more than 4, so not more than 4. So that would be 4 and less. So that means I need to add up all these. So I've got 30, 57. So 57 out of 64. All right. And then it says at least 3 heads and fewer than 6. So at least 3, right? If it's at least 3, then I need 3 or more. So that would be this way. But fewer than 6, so not 6, anything less than that. And so you can see the overlap here, which would be 3, 4, and 5. So that would be the 20 and the 15, 35 plus 6 would be 41. Okay? Now, that's all fine and dandy, but you saw how, well, you felt it as you did it tonight in your homework. You felt how difficult it would be to do this, and it's only 6 flips, right? We're not even talking about a die that has 6 possibilities or anything like that. Okay, so I want to show you something on your calculator that will help you to answer this question. All right, so let's move over to the calculator. All right, so here we are at the calculator. I'm going to show you how to do those calculations on your calculator without even having to draw a tree diagram. Right, now this only works if it's a binomial probability. Now the flipping of the coin we know is a binomial probability because either it's true or false, either it's heads like we want or it's not heads. We're repeating the same thing. We're going to have a set number of trials, right? In this case, we flipped it 6 times, so we had a set number of trials. And then lastly, the third thing is that the probabilities need to stay the same every time. A coin, when you flip it, is going to have the same probability of hitting heads every time. It doesn't matter if it's fair or not, as long as the probability of getting heads is equal every time. All right? So here's how we're going to do this. We're going to go into our menu. Okay, and you see a lot of fun things over here. Probability, and we're going to go into distributions. Now, when you go into distributions, you can see down here at the bottom a word that is familiar, which is binomial. So this is Binomial PDF. So this is a binomial probability distribution function. So if your distribution is a binomial distribution, then you can put in here the number of trials. We flipped the coin 6 times. So we're going to put 6 there. Okay? The next thing is the probability of success. Well, that's the probability of getting what we want, which is heads. That probability was 1/2, and you can type in 1/2 or you can type in 0.5. It doesn't matter. And then here, this is the value that I want, right? Now, in that first question, the question was, what is the probability of getting exactly 3 heads? Okay, so in order to get 3 heads, X is what I want. I have a 0.5 probability of getting a heads, and I want 3 of them. And now when I push OK, what it's going to do is it's going to go through that tree and it's going to calculate everything for us, and it's going to give us 0.3125. All right, now if you'll go back to our problem, the previous problem that we were just looking at, you'll notice that this decimal right here is exactly the same as the fraction that we had come up with. All right, now that's pretty cool. Now, that's cool, but there's something even cooler. All right, so let me show you another one. Okay, the second question was we needed to find the sum of all the probabilities up to 4 heads, right? And so in order to do that, we don't want one probability. You could do Binomial PDF for 0, 1, 2, 3, and 4. Okay, but there's an easier way to do it. Again, we can go in here to probability, go down to distributions. You see that binomial, but actually below that, the next one is Binomial Cdf. And what that is Binomial Cumulative distribution function. So we're going to click on the Binomial Cumulative distribution function. And the number of trials, again, we're flipping the coin 6 times. The probability of success of getting a heads on a single test is 0.5. Now this time we want everywhere from 0 up to 4, right? And so when we do everywhere from 0 to 4, this is going to count the probability of getting a 0, a 1, a 2, a 3, or a 4 of what we want, which is heads here, out of the total number of trials of 6. And so we should be able to just go OK here. And look at this. We got 0.890625. And if you compare that to the probability that we got in the last question, do the division, you're going to get exactly the same number again. Is that snazzy or what? So in class, we're going to practice that a little bit more, but I wanted to introduce it to you today so that in class we can go straight into solving some problems and trying some different things out. All right, so good luck. Hopefully that was helpful and gives you hopefully you're having a little bit of a sigh of relief that you're not going to have to do something like that heads, tails, 6 coin flips again, because now you have a simpler way to deal with it. All right, that's all.